Alright guys, so in this video here we're going to introduce two new definitions and look at some few example. But before we get there, let's look at some functions that we already know or studied so far in this class that we can describe the behavior of the concavity of the graph. So let's label this as examples. Let's look at examples. Okay, let's look at these three examples. We have a function that is e to the x. And then we have a function that is natural log of x. And then we have a function that is x to the third. Okay. So let's graph these two functions. So e to the x, we know that is going to be like that. You know what? Let's go ahead. Yeah, actually, let's just do that. And then this is going to be 0, 1 there. Natural log function, so it's going to be like this. Okay. Oh, oops. X, y, x to the third power is going to go through the point 0, 0. It's going to go like that. There it is. Okay. So here's a three graph of these functions that we kind of studied already a little bit, but again, we're not going to do a lot of graphing in this class. I just want to introduce the next definition using these graphs of these functions here. Now notice that the e to the x, the graph is like this. So that's an example of concave upward right here. Okay. So we're gonna say f is concave upward on negative infinity to positive infinity. It doesn't change the concavity at all. Now we can verify this by find the second derivative of the e to the x and show that it's always gonna be positive no matter what value you're actually looking at. Now let's look at natural log of x. So natural log of x is very similar. It's kind of going up that way there. So it goes from from low to high. So that's an example of concave downward. So there it is. Okay. So concave downward. And again, we can verify this by finding the second derivative of natural logs, and it turns out it's going to be a negative function. So therefore, the second derivative is always going to be negative, no matter what value of x that we plug in. So we can say in this case that g is concave downward, down on 0 to positive infinity. The last graph here, x to the third. Now, I want us to pay a little more close attention to this one. Now, notice that from negative infinity to 0, the graph kind of looked like that, okay? And then from 0 to positive infinity, it's kind of look like that. Now, if we draw the slope of tangent lines, notice that the slope of tangent line there is positive or positive, but it's decreasing because it's getting less steeper. But from 0 to positive infinity, the slope of tangent line are increasing and increasing. So this is positive derivative and this is negative derivative. So what's happening in this case here, we say that the derivative goes from negative to positive. Or if we want to describe this using the second derivative, we say that the function of the graph is concave up. It's going to no, this is concave downward. So the graph go from concave downward, and then once it passes 0, it's going to concave up. Okay, so concave down, and then concave up. So we say that y is changing the concavity at x equals 0. Okay, so the point where the graph changes the concavity, guys, we have a name for that. So in math, we call that point there. So let's say definition. Okay, we say that an inflection point, let's call it inflection point, okay, is a point on the graph of a function where the concavity changes. Meaning it could go from positive to negative, meaning it could go from upward to downward or downward to upward, right? So it could go from, upward to downward or downward to upward. Okay, what this means is that the second derivative, the sign of the second derivative, so f del prime can go from, positive 0 to, negative, meaning less than 0, or f del prime can go from negative to positive. Okay, so that's what we can relate in terms of what upward and downward concavity is. So now, in math, the name for that point where the concavity changes, we call that the point of inflection. In business or econ, I think you guys will be more familiar with this term here. So let me just briefly introduce that term. So in economics, the point where the graph changes concavity or changes the rate of the functions increasing, decreasing, this point here. All right, so in business or economics, we call that point there is point of diminishing returns. Okay, so this is where at that point or anything after that point there, the rate of return is much less than before that point. And that's what it's really mean there. Diminishing means not much anymore. Returns mean the profit or the revenue, whatever you want to look at with the sales. So the last video of this lesson, I'm going to show you guys an example of an application of point of diminishing returns. So now I'm going to go over an example how to find inflection point of a given function. But this example may take the entire 10 minutes. In class, usually it would take me 20 minutes. I would pause and show the step. I think in video-wise, it's probably going to take me 10 minutes. So I'm going to go ahead and pause this video. And then the next example, the next video, I'm gonna go over an example, how to find inflection point, how to tie, the first derivative, the second derivative. What does it mean for function increasing, decreasing? So I'm gonna try to hit it all together, both section 4.1 and 4.2.